the James Webb Telescope recently launched by NASA. So today I am going to talk about it. The James Webb Telescope is the largest, most powerful space telescope ever built. It will allow scientists to look at what our universe was like about 200 million years ago. The telescope will be able to capture images of some of the first galaxies ever formed. It will also be able to observe objects in our solar system from Mars outward, look inside dust clouds to see where new stars and planets are forming, and examine the atmospheres of planets orbiting other stars. It was launched on 25th December 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The US National Aeronautics and Space Administration (NASA), European Space Agency (ESA), and the Canadian Space Agency (CSA) were involved in the mission. The Webb telescope is as tall as a 3-story building and as long as a tennis court. It is so big that it has to fold origami style to fit inside the rocket to launch. The telescope will unfold sunshield first once in space. The James Webb Telescope sees universe in light that is invisible to human eye. This light is called infrared radiation and can feel it as heat. Firefighters use infrared cameras to see and rescue people through the smoke in the fire. The James Webb Telescope will use its infrared camera to see through dust clouds in our universe. Stars and planets form inside these dust clouds, so peeking inside could lead to exciting new discoveries. It will also be able to see objects like the first galaxies that are so far that the expansion of the universe has made their light shift from visible to infrared. The Webb telescope's cameras are sensitive to heat from the sun. Just like you might wear a hat or a visor to block the sun from your eyes, Webb has a sunshield to protect its instruments and mirrors. The telescope's sunshield is about the size of a tennis court. The temperature difference between the sun-facing and shaded sides of the telescope is more than 600 degrees Fahrenheit. How scientists communicate with Webb or even any other telescope? Many of NASA's spacecraft are exploring our planet, our solar system, and beyond. These spacecraft send information and pictures back to Earth using the Deep Space Network. The DSN is a collection of big radio antennas in different parts of the world. These DSN locations near Canberra, Australia, Madrid, Spain, and Goldstone, California. Those sites are almost evenly spaced around the planet. That means as Earth turns, we never lose sight of a spacecraft. When any spacecraft send images and other information to these big antennas here on Earth, the antennas also receive details about where the spacecraft and how it is doing. At the same time, NASA uses the DSN to send list of instructions out to the spacecraft. But in order to communicate with the DSN, the robotic explorers have a lot to do. The tools they use to communicate can be too heavy, take up too much room, or use too much power. Small antennas on the spacecraft have beam weak signals back to Earth. The farther away a spacecraft is, the larger the antenna you need to detect its signal. The largest antenna at each DSN site is 70 meters in diameter. The most distant objects that the DSN communicate with are NASA's two Voyager spacecraft. Because the Voyagers are so far away, their signals to the antennas are very weak. In fact, the power that DSN antennas receive from the Voyager signal is 20 billion times weaker than what is needed to run a digital watch. Engineers have figured out ways to boost signals so they can be heard loud and clear. Thanks for watching. Don't forget to like, share and subscribe to my channel.